Hi, uh, today I'm gonna talk about why you should apply physics to exercising. And as you can see from a notebook that I listed Henneman's size principle, our Newton equations and joules. So first off, if I weigh 44 kilograms and we can apply physics to our daily routine of exercising by as you can see that from the equations, weight 44 multiplied by 9.81. This 9.81 is the gravitational pull, or the meters in terms of scientific explanations. It equates to newtons. So if I weigh 44 kilograms, if we multiply that by 9.81, it would equate to 431 newtons, and that's the force that I need in order to carry my body. But it's not included there the full meters. For example, the full range of motion is not included there. I just have to sustain my weight there. And if we include this right, yeah, it's getting blurry. Alright, it's now clear. If we include these joules, which is newtons multiplied by 1 meter, it equates to work, which is joules. For example, if I weigh 44 kilograms multiplied by 9.81, so we get the 431, and we should multiply it again by 1 meter. So if I stand at 5'7", I need this distance. As calculated by joules, and this height difference from the eccentric and concentric phase is affected by that equation. So we now have this 647 joules. Today we're gonna talk about the Henneman size principle. Oh, I may have forgotten this one. I forgot another. The work, the power. Yeah, the power. The power is the total amount of your capability to finish something at a specified time. For example, if my work is 647 joules, then if I finish my squat within just 2 seconds, right? 2 seconds. If I finish that, I would have 323 power, because as you can see from the equation here, work, which is joules, divided by time, power, that equates to power. So if I finish my squat 1 rep within just 2 seconds, then I would have this 323 power. And if I limit my squat by time, let's say if I finish my full 1 rep squat within 5 seconds, right? 1, 2, 3, 4, 5. Then I would have 129 power, right? How did I calculate that? Let's say, we got the amount of newtons, right? 431 newtons, and we multiplied it by 1.5 meters, because 1 meter is equal to 3 inches. So I stand at let's say 5'7", yeah, 5'7", 5 inches, and 5 inches, 5 feet. Sorry about that. 5 feet and 7 inches, right? So 1 meter is equal to 3 feet. Yeah, 1 meter is equal to 3 feet. Then we multiplied the 431 joules, newtons, by the meter, which is 1.5. 1.5. That equates to 5 feet and 7 inches. So now we're gonna talk about the element size principle. Here you can see the diagram. I just drew this. I'm not good at I'm good at painting. I'm good at drawing. This is the element size principle. As you can see, the small diameter neurons. Neurons, motor neurons. I'll explain that in another video. But today we're going to talk about muscle fibers, and muscle fibers are composed of tiny myofibrils, and there are these motor neurons attached to the organs. Muscle fibers. These are the slow fatigue muscle fibers. What does that mean? Based on element size principle, slow fatigue muscle fibers, it helps us sustain our body weight. Right? Like if we're just walking, then what plays in the place is our slow fatigue muscle fiber, and these bigger ones, these are the fast fatigue muscle fibers. These are the large diameter neurons, and this is the small diameter motor neurons. And as it moves to the right, our muscles become more explosive. These large diameter motor neurons are actually explosive, and these small diameter motor neurons are fast fatigue, and they can carry more weight than these large diameter motor neurons. Right? This is getting deeper, and I know this is hard to explain. But as soon as you've understood the neurons and how those neurons are attached to our muscle fibers, then you'll understand. But our muscle fibers are like this, right? And based on element size principle, we exert our body, uses strength, and it is supported by these muscle fibers. Millions of muscle fibers, and only few large diameter muscle fibers, which is fast fatigue muscle fibers. This actually, if you've heard about the type 1 and type 2 muscle fibers, type 1 muscle fibers are those that are slow fatigue, and those type 2 muscle fibers are the fast fatigue muscle fibers. So now you understood, we're gonna illustrate how that works. So if I squat, like for example, we can actually connect this to the equations. If I squat, alright, if I perform full moon squat, in an explosive way, right? Explosive, right? Fast, right? It's getting hard.